The Energy Warden Policy module is a web-based system for monitoring the real-time in-situ performance of different renewable energy devices installed in a building. These are photovoltaic, wind turbine, solar thermal, and geothermal devices. The Energy Warden Policy module monitors also the performance of the building as a whole in terms of CO2 emissions. The Energy Warden Policy tool functionality is based on existing international performance standards. These standards have been appropriately adapted for in-situ monitoring since these are usually meant for laboratory use. The user should first register his product by inserting the name, contact details, company name, the product serial number if it's available, and the password. Then the user should log in into the account. In order to monitor performance and various other operating parameters of a new system, either photovoltaic, wind turbine, solar thermal, or geothermal, initially the user should press the plant configuration button in order to import the plant data. Select the power plant type from the drop-down menu. There are 4 options: photovoltaic, wind turbine, solar thermal, and geothermal. Then press the New Plant button and insert the requested data. When you are finished with the plant configuration data, by pressing the button Sensor Data Import, the installed system should be selected from the drop-down menu and the sensor data will be uploaded and imported to the database automatically. It should be pointed out that the Energy Warden Policy module can plot a wide range of different charts, for example, area charts, bar charts, column charts, line charts, and 3D charts. Moreover, the Energy Warden Policy module can plot results for 3 different pre-selected periods: the 7, the 30, and the 365 days. Also, there is the option of showing all the available data by selecting the option All Available Data. Finally, a specified period of time can be manually selected using the option Data Range. The geothermal module allows the monitoring of the system coefficient of performance, the COP, in case of heating, and the system energy efficiency ratio, the EER, in case of cooling. As mentioned earlier, the first step that needs to be done is to insert the system plant configuration data. Initially, the location of the system should be inserted. Then we proceed with the data input. These are the heat pump type, the heat pump total heating load in kilowatts, which is the heat pump heating capacity at standard operating conditions at delta T 5 degrees centigrade. The heat pump total cooling load at delta T 5 degrees centigrade, which is the heat pump cooling capacity at standard operating conditions. The COP at temperature difference delta T 5 degrees centigrade. And the EER at temperature difference delta T 5 degrees centigrade. Then the sensor data should be imported. For that reason, the power plant type and the examined plant should be selected. Using the Select Sensor drop-down menu, the 4 measured values could be uploaded and imported to the geothermal module. The measured values are the following: the fluid outlet temperature, which is the temperature of the fluid at the outlet of heat pump evaporator. The fluid inlet temperature, which is the temperature of the fluid that returns to the heat pump evaporator. The electrical energy in kilowatts, which is the consumed power of the system including pumping units. The mass flow, which is the mass of liquid that circulates to the pumping systems of floor heating or fan coils. After the data importing, the graphs for each parameter could be plotted. By selecting the Performance Monitoring button, the graphical representation of each measured value can be shown. For example, La Catania plant is selected from the drop-down menu and from the measured values, the fluid outlet temperature. Then, as mentioned earlier, there are various chart types to see the monitor data: area chart, bar chart, column chart, line chart, and 3D chart. Also, you can define the time period of the plotted results. The calculated values are the temperature difference, the power in kilowatts, the instant COP and EER, the mean value of COP and the EER, and the CO2 savings. The temperature difference refers to the delta T between evaporator inlet and outlet. The power Q in kilowatts is the consumed power of the system. The instant COP and EER refer to the system efficiency for heating and cooling respectively. The mean value of COP and EER is the monthly average system efficiency for heating and cooling. Finally, the CO2 savings represents the carbon emission savings from the geothermal system. By pressing the reporting button, a full report of the results can be printed. Thank you for your attention.